Respond only in JSON isn't a specification. It's a wish. And the model grants it about 9 times out of 10. Welcome to the Atlas. You've asked for structured output and gotten it right most of the time. This is how you make it right by construction. And it starts with how literally the model reads you. It's the bug that feels personal. Your extraction worked all through testing, you shipped it, and now it fails one call in 10, a field missing, a number wrapped in quotes, a stray sentence before the brace. Nothing changed in your code. So you add important, respond only invalid JSON in all caps, and you hope harder. Here's the thing you can feel, but haven't named. You've been coaxing the model when you could be specifying. Respond in JSON is a blank lot with a polite request. The model interprets you literally, so a vague ask leaves it free to add a sentence or quote a number, and a precise spec doesn't. Vague in, variable out. Precise in, predictable out. The model isn't the unreliable part. Your criteria were. Respond in JSON is a wish. A precise spec is a contract. And there isn't one way to specify. There's a spectrum. Here's the map. Specifying isn't one move. It's a spectrum of how binding you make the criteria, and you choose the rung based on how much the job needs. 3 surfaces you can specify against. The prompt. Tell the model exactly what format you want and show one example, cheap, flexible, but still a nudge. The response. When the answer itself must conform, you hand over a schema through the output config format. Now the response is constrained, not merely requested. And a tool's inputs. When the structured data is the arguments to a function the model calls, strict, set to true, makes the tool's input schema binding. Same spec language at every rung, fields, types, allowed values, which are required. What changes is whether it's a request or a rule. You don't pick one of these forever. You pick the rung each job needs. Here's why the line between a nudge and a constraint is real, not rhetorical. It lives one level below the prompt. At the moment the model picks its next token, the documentation says it directly. Unlike prompting the model to return valid JSON, structured outputs compile your schema into a grammar and actively restrict token generation during inference. A prompt asks the model to try. A schema removes the invalid options from what it's even allowed to say. That's also why the docs steer you up the spectrum. When you need valid JSON that conforms every time, use the schema. When you need flexibility beyond a strict schema, the prompt techniques are the right tool. A prompt changes what's likely. A grammar changes what's possible. That single distinction is the whole spectrum. So start at the cheap end. Start at the cheap end. Before any parameter, you can get a long way by stating the criteria precisely in the prompt, and the docs are specific about how. Precisely define the output format in JSON, XML, or a template, so the model understands every element you require. The documented example doesn't say respond in JSON. It names the exact keys, the allowed values for each, and the shape of every item. Then show one concrete example of the output you want. Examples train the shape far better than abstract rules. And wrap mixed content in XML tags, so the model parses your intent without ambiguity. One older trick is gone. Prefilling the assistant turn with an opening brace to force the shape is no longer supported on the current models. The documentation's own remedy is to ask precisely, or to move up to the schema. Even on the cheapest rung, specify beats ask. That alone fixes most flakiness. When the structured output is the model's answer itself, a sentiment record, a list of issues, a row for a database, you move from asking to constraining. One parameter and the criteria become a rule. You add an output config object whose format is typed JSON schema, and you hand it your criteria as a schema. The properties and their types the required list, which fields must appear, and additional properties set to false, which says no other fields may. The response then comes back as valid JSON in the first content block's text field, not requested, constrained. And you don't have to hand write the schema. Define it as a pydantic model or a Zod schema, and the toolkit generates it, parses the result into a typed object, and even quietly fixes the unsupported keywords it can. One migration note, this used to be the output format parameter, and it now lives at the output configs format field, generally available, no special header. On this rung, the criteria stop being a suggestion. The properties say what fields exist. The required list says which must appear. Additional properties false says nothing else may. The response is bound to it. Sometimes the structured data you need isn't the prose, it's the arguments to a function the model is calling. A booking tool needs passengers as an integer, and the model hands you the string 2. Same unreliability, different surface, and the same fix moved onto the tool. Set strict, set to true, as a top-level flag on the tool, alongside its name, description, and input schema. Now the tool's input schema is the binding spec for the arguments, and you write it the same way you'd write any criteria, types, and enum to fence the allowed values, the required fields. The model can no longer hand you the string 2 or 2. It hands you the integer 2 every time, with no validate and retry wrapper. It's the very same grammar engine as the response schema, just pointed at the tool's inputs. One governance note: keep sensitive data out of the schema itself. It should live in the message content, not in field names or allowed values. The parameter is the easy part. The skill is writing criteria precise enough that the right output is the only output. 4 moves do most of the work, and they're the same on every rung. First, types. Say integer, not a number. The schema enforces it. Second, an enum. When a field has a fixed set of valid values, a status, a category, a label, list them as an enum, and the model can only pick from your set. The docs say it directly. For classification, use a tool with an enum field holding your valid labels. Third, the required list plus additional properties false. Required says which fields must appear, and additional properties false says no others may, together, exactly these fields. And fourth, for a constraint the schema can't hard enforce, say a minimum value, carry it in the field's description, the way the toolkit itself does when it strips an unsupported keyword. Every one of those is the same instinct: leave the model fewer ways to be wrong. Here's where confident people get surprised. JSON schema is supported does not mean all of JSON schema. The criteria you can hard constrain are a subset, and stepping outside it doesn't bend the rule, it rejects your whole request. The supported set is generous. Every basic type, enums, the required list, additional properties, string formats. But numerical limits like minimum and maximum, string limits like max length, and recursive schemas are not supported. Use one, and you get a 400 error, the whole request rejected. The move when you need such a rule, carry it in the field's description instead. And one more boundary. Even a schema-constrained response assumes the generation finishes and isn't refused. A refusal or a token cutoff still escapes the schema. Handling that is the recovery playbook, a unit of its own. Here's the beat that separates knowing the names from knowing the edges. 4 confident answers that feel right and fail anyway. Trap 1. I asked for JSON, so it's specified. But a precise prompt is a nudge. Specifying the shape is a real lever only a schema guarantees. Trap 2. Structured outputs and strict tool use are the same. Pick either. They're different surfaces. The output config format controls what the model says. The strict flag validates how it calls your functions. Different jobs, and they're meant to combine. Trap 3. JSON schema is supported, so add a minimum. It's a subset. Numerical limits, string length limits, and recursive schemas all return a 400. Trap 4, more words in the prompt means more reliable. Past the schema line, it doesn't. Reliability there comes from constraining, not coaxing, and even a constrained response is bounded by a refusal or a cutoff. Every trap is the edge of a lever you already learned. The one who fails picks the answer that's true most of the time. The one who passes knows which lever the job needs. Put it on one screen. You reach for structured output. Here's the decision in order. First, decide how binding the job needs the criteria to be. Need flexibility or general consistency? A precise prompt with an example. Need the answer to conform every time? The output config format? Need a tool's arguments to conform? Strict, set to true, and combine the two schema surfaces for an agent that calls tools cleanly and returns structured results. Then write the criteria the same way every time, types, enums, the required list, and a description for what the schema can enforce. And stay inside the supported subset or the request 400s. Reliable structured output isn't a retry bolted on after the fact. It's a specification chosen upfront, the surface, the criteria, and the edge. The model takes you at your word, so give it the exact words. 5 things to carry out of this one. The model takes you literally, so specify, don't hope. Precision is a spectrum, a precise prompt, a response schema through the output config format, or a tool's input schema with strict set to true. A schema constrains where a prompt only coaxes. Write the criteria tight, types, enums, required, and a description for the rest. And mind the edge. The supported schema is a subset, and even a guarantee is bounded. That's the precision spectrum. Specify the surface, write the criteria, mind the edge. Thanks for watching the Atlas. Subscribe for the next prompt engineering unit, system prompts, and XML structure, the scaffolding that shapes how the model thinks before it answers. See you there.